The coefficient of kinetic friction for a 22 kg box on a ramp is 0.10. What force is required to push it down along a 6 degrees incline and achieve a speed of 60 km per hour at the end of 75 meters? An object placed on a tilted surface will often slide down the surface. In physics, a tilted surface is called an inclined plane. In problems involving inclined planes, gravity is the acceleration force, yet the acceleration is not vertical. Objects are known to accelerate down inclined planes because of the unbalanced force. Common examples of inclined planes are hills and ramps. For example, we have an object here. Say this is a brick and nakalagay siya sa horizontal surface. So kapag inilagay natin yung forces na nag-act sa kanya, unang-una we have the weight and yung normal force na binibigay ng floor dun sa kanya. And for example, magkakaroon tayo ng applied force here. Meron ko kontra dito na force of friction. For example naman, nakatilt na yung ating surface. So we have an angle here, angle of inclination. Ang weight natin is directly downward pa din. From here, ganito pa rin ang ating weight. Pero ang normal force is again perpendicular to the surface. That's why we called it as normal. This is the normal force. For example, we have an applied force here. So, magkakaroon tayo ng acceleration. Or even we don't have a force applied, pwede siyang magkaroon ng acceleration dahil dun sa kanyang pagkakatilt. And dahil dito, magkakaroon tayo ng force of friction. For example, gagawan natin ng free body diagram yung ating second figure. So we have weight here and the normal force with an angle theta from the horizontal. This is the force of friction and this is the applied force. Now, to solve for the unknown quantity na kailangan nating isolve, kukunin natin lahat ng components ng two-dimensional forces na to. Sa Fn, kukunin natin yung Fny and Fnx. Same with force applied, x and y components. Force of friction, we have force of friction y and force of friction x. Now, para mas madali maging problem solving natin, pwede nating itilt yung mismong free body diagram natin. Isusunod natin dun sa two-dimensional forces. For example, eto na yung ating magiging normal force. And this is the applied force. This is the force of friction. And this is the weight. In this free body diagram, ang in-adjust na natin is yung weights. Siya na lang yung kukunan natin ng x and y component. Para malesen natin yung pag-solve ng iba't ibang components dun sa two-dimensional forces natin. Like the force of friction, normal forces, and yung force applied. In this figure naman, so same ang maging nangyayari dito. Basta alam lang natin na ilagay kung saan nag-a-act yung mga forces. Unang-una is yung weight niya na directly downward. Yung normal force na perpendicular sa surface. And yung force of friction na pakontra dun sa sliding motion nung object natin. Example number 1. A sled is tied to a tree on a frictionless, snow-covered hill. If the sled weighs 77 Newton, find the magnitude of the force exerted by the rope on the sled and the normal force exerted by the hill on the sled. Again, kagaya ng nabanggit natin kanina, when an object is on a slope, mas convenient na gamitin natin yung tilted coordinates so that, for example, yung normal force natin ay nasa y direction na and yung magiging force applied natin or yung additional forces na mag-a-act sa object natin is in the direction where hindi na natin kailangan gumamit ng angle. So first, to solve for this problem, ilagay muna natin yung forces na nag-a-act. First is yung weight directly downward. And yung normal force, perpendicular to the surface. And merong force dito, force tension, dahil pahila. So this is force tension. According to the problem, yung heel is snow covered, that's why it is frictionless. In the absence of friction, the heel exerts no force on the sled. And dahil yung sled is at rest, by second law of motion, walang acceleration yung sled. So draw natin yung free body diagram. Ito na yung susundin natin na direction. Yung normal force natin is directly nasa y na siya agad. And ang mag-a-adjust na lang is yung weight, which is pa ganito. So this is the angle theta. We have 30 degrees. And ang force tension natin is dito. Normal force and the force tension. This is the weight. We are asked to find the magnitude of the force exerted by the rope or yung force tension. Another is the normal force. So, dalawang forces ang hinahanap sa atin dito. Yung normal force is nasa y direction, is yung force tension naman is nasa x direction. Gagamitin natin dalawang component to solve for that. Let's start with the x direction at x. By second law of motion, mass times the acceleration at x, we have no motion, therefore we have no acceleration. This is 0. And by summation of forces, 0 na agad yan. Ang nag-a-act na forces sa x is, first, kuhanin natin yung components ng weight. We have weight x and this is weight y. So we have 2 na nag-a-act na forces sa x direction, which is yung force tension at saka yung weight x or yung x component ng weight natin. Assuming this is the positive sides, force tension positive minus weight at x component. Again, the net force is equal to 0 kasi wala tayong motion. Solving for the force tension, this is directly equal to positive na to kasi nilipat doon, positive weight at x. Force tension is equal to weight. X component is sine theta. Bakit naging sine theta? Kasi yung angle natin is nandito from the vertical, hindi from the horizontal. By substituting the known quantities, ang weight ng sled is 77 Newton. Sine 30 degrees, force tension is equal to 38.5 Newton. For the normal force naman at y direction, by second law of motion at y direction, this is mass times the acceleration at y, and again we have no motion, therefore there is no acceleration. This is 0 and this is 0 na agad sa net force. By summation of forces, sa nag-a-act na forces sa y component is first yung normal force na positive and yung y component ng weight natin na negative dahil pababa siya, minus weight y. Solving for the normal force, this is equal to positive weight y. Normal force is equal to weight cosine theta. Again, naging baliktad yung pag-apply natin ng angle dito kasi yung angle theta natin is from the vertical, hindi from the horizontal, unlike the regular na problems na sinosolve natin. So normal force is equal to, ang weight is again 77 Newton, cosine theta 30 degrees. By calculating, normal force is equal to 66.7 Newton. Unlike its value on a horizontal surface, yung normal force is less than the weight of the sled when the sled is on the slope. This is because only part of the force of gravity or yung weight natin at the x component is acting to pull the sled down the slope. Yung y component of the force of gravity or yung weight balances the normal force. So this is example number 1. Example number 2. The coefficient of kinetic friction for a 22 kg box on a ramp is 0.10. What force is required to push it down along a 6 degrees incline and achieve a speed of 60 km per hour at the end of 75 meters? So we have given an acceleration here. Ang hinahanap sa atin is yung force required para ma-move natin yung 22 kg box Doon sa napakaliit na inclination angle, we have 6 degrees. And umabot siya hanggang dun sa distance na 75 meters. Let's draw first the figure. So this is the inclination. We have angle 6 degrees and this is the box. This is the weight directly downward and this is the normal force. Ang hinahanap again natin is yung force required or yung force na i-apply natin dito para mai-push siya and makapagbigay ng speed of 60 kilometers per hour. This is force applied. So, ito ang hinahanap natin. And again, binigyan tayo ng coefficient of kinetic friction. Therefore, magkakaroon tayo ng motion na nagbibigay ng resisting motion dito, yung force of friction nga yun. In creating a free body diagram, i-consider natin na this is the y direction and this is the x direction para ito na yung ating normal force. Ang mag-a-adjust na lang again is yung weight. This is the weight. This is the angle theta. This is the force applied. And this is the force of friction. To solve for the force applied, gagamitin natin yung x component. So at x component or at the x direction, horizontal direction, gagamit tayo ng summation of forces. Ang nag-a-act na forces sa x, kuhanin muna natin yung components ng weight. This is weight x and this is weight y. We have 3 forces na nag-a-act sa x direction natin. Yung force applied na required or yung hinahanap natin, weight at x, and yung force of friction. So assuming this is the positive sides, upward y and the right x, we have positive force applied plus weight sub x minus force of friction. And by second law of motion at x, this is mass times acceleration at x. Again, hindi natin pwedeng i-zero yung acceleration kasi magkakaroon nga tayo ng motion. And we have a given speed na 60 kilometers per hour. So, itong 60 kilometers per hour na to, pag kinonvert natin sa meters per second, we have 16.67 meters per second. Ang gagamitin na natin is yung 16.67 meters per second para makapag-adjust siya dun sa ibang units natin. Now, this is equal. So, mass times the acceleration at x is equal to positive force applied plus weight x minus force of friction. Ang problema, hindi pa natin alam yung acceleration but we have given a speed of 60 kilometers per hour or in meters per second, we have 16.67 meters per second. In the problem, ang sabi is to achieve a speed of 60 kph. Ibig sabihin, nag-start siya from rest, binigyan mo siya ng force applied na hinahanap nga natin, and then pagkatulak natin dun sa box, nagkaroon ng motion yung box hanggang umabot siya ng 75 meters. And dun sa position na 75 meters, nagkaroon siya ng speed na 60 kilometers per hour. Meaning, yung 60 kilometers per hour na yan is the final velocity. Ang initial velocity natin is 0. And yung 75 meters na yan is the distance na gagamitin natin to solve for the acceleration using an equation from kinematics. To solve for the acceleration at x using kinematics equation, we have v square equals v sub o square plus 2a x minus x sub o. Again, say for example, eto yung box, tinulak siya dito, nagkaroon ng force applied dyan. From initial velocity natin na 0, mabot siya dito. We have, this is the x and this is the initial position ng x natin is 75 meters. And this is the final velocity where nagkaroon siya ng 60 kph. Ang hinahanap natin is yung acceleration. Initial velocity is 0. Initial position is 0. We have v square equals 2ax na lang. Solving for acceleration, we divide both sides by 2x. Cancel. Acceleration is equal to, ang v natin is 16.67 meters per second quantity square divided by 2 times 75 meters. Ang acceleration natin is equal to 1.853 meters per second square. Hindi pa yan ang final answer. Ang hinahanap natin is yung force applied. Alam na natin yung acceleration at x. Pwede na natin i-apply dito sa equation na to solve for the force applied. M times the acceleration at x equals force applied positive plus weight x minus force of friction. Solving for the force applied is equal to mass times the acceleration minus weight sub x plus force of friction. Substituting the given values, force applied is equal to, ang mass natin is 22 kilograms times the acceleration na 1.853 meters per second square minus weight x or simply the mass times gravity sine theta. Ang mass natin is 22 kilograms again times the gravity na 9.81 meters per second square sine 6 degrees plus force of friction. Ang equation natin is coefficient of kinetic friction times the normal force. Alam na natin yung coefficient of kinetic friction. Problema is hindi pa natin alam yung value ng normal force. To solve for the value of normal force, dito na lang natin ilagay. So, ang gagamitin natin is yung y component. At y, dalawang forces yung nag-act sa y. So, by summation of forces at y, we have positive normal force minus weight y. Kaya lang, by second law of motion, kailangan pa rin natin i-consider at y, mass times acceleration y, wala tayong naging acceleration or wala tayong naging motion sa y component. Ito, hindi naman siya umangat na paganyan, hindi rin naman siya bumaba na paganyan. So, meaning, wala tayong motion. This is 0 equals force, normal force minus weight y. Or simply, normal force is equal to weight y. Normal force is equal to mass times gravity cosine theta. So, ito na mismo yung ilalagay natin dito. Coefficient of kinetic friction na 0.10 times the normal force, we have the value here. Ang mass is 22 kilograms times 9.81 meters per second square again, cosine 6 degrees. Pwede na natin calculate ngayon by calculating force applied is equal to 20.46 Newton. So, this is the force required para maipush natin yung box and magkaroon siya ng motion, mag-accelerate hanggang magkaroon siya ng speed na 60 kilometers per hour and ma-reach niya yung layo na 75 meters. So, this is example number 2. A flatbed truck slowly tilts its bed upward to dispose of a 95 kilogram crate. For small angles of tilt, that crate stays put, but when the tilt angle exceeds 23.3 degrees, the crate begins to slide. What is the coefficient of kinetic friction between the bed of the truck and the crate? In this figure, makikita na natin meron na tayong tatlong forces na nakalagay. We have the weight, the normal force, and the friction due to static. So again, para mas madali, sa free body diagram natin, i-align na natin siya sa coordinate system para again, yung normal force is at the positive y direction and yung force of friction is nasa negative x direction. So this is the normal force, this is the weight, and this is the force of friction. We have the angle here, and ang components ng weight natin is first, ito yung ating weight x, and ito ang ating weight y. This is the positive sides. Doon sa part na kapag yung angle is equal na sa 23.3 degrees, mag-uumpisa nang gumalaw yung crate. Pero, below that angle, naka-rest lang siya at hindi gumagalaw. And kapag hindi siya gumagalaw, there is no motion, there is no acceleration. We have zero acceleration in both the x and y direction. And in addition, kapag nandun na siya sa point na gagalaw na siya, ibig sabihin nun that yung magnitude ng static friction ay nandun na sa maximum value. Thus, isi-set natin yung second law of motion natin at y, no acceleration, this is 0, para mahanap yung normal force. And then, gagamitin natin yung second law of motion at the x direction para mahanap natin yung coefficient of static friction. We have two main known quantities, yung mass, which is 95 kilograms, and yung angle of inclination na 23.2 degrees. Ang pipiliin natin is 23.2 degrees. y. Pag nandun na siya sa 23.3 degrees, gagalaw na siya. Ang concept ng static friction kapag yung object natin is at rest, nun mag-occur yung static friction. So meaning, ang gagamitin natin ni angle is yung below 23.3 degrees and yung maximum, we have 23.2 degrees. By summation forces at y, we have the positive normal force minus weight ng y. So this is 0. Normal force is equal to weight y. At ang weight y natin is mass times gravity cosine theta. Again, cosine theta sa y natin kasi the angle is from the vertical. By second law motion naman natin at x, this is mass times the acceleration at x. We have no motion kasi coefficient of static friction ang hinahanap natin. And nandun tayo sa angle kung saan nandun yun yung maximum angle niya pero hindi pa siya mag-move. We have 23.2 degrees. So by summation of forces, this is 0 and we have weight x na nag-act sa positive x direction minus yung force of friction natin. So this is 0. 0 equals weight of x minus ang force of friction natin is coefficient of static friction times the normal force. We have weight of x equals coefficient of static friction. Ang normal force natin is equal dito na na-derive natin from the second law of motion and yung summation of forces natin at the y direction. So, ilagay na natin as mass times the gravity cosine theta. Ang weight x naman natin is equal sa mass times gravity sine theta. And again, this is equal sa coefficient of static friction times the mass times gravity cosine theta. Solving for the coefficient of static friction, pwede na natin siyang isolve ngayon. We cancel the mass and yung gravity. Ang matitira sa atin is sine theta equals coefficient of static friction times cosine theta. Dividing both sides by cosine theta, this is cancel. Coefficient of static friction natin is equal to sine over cosine is equal to tangent, and this is tangent theta. Coefficient of static friction is equal to tangent. Ang angle natin is 23.2 degrees. By calculating, this is equal to 0.429. In general, kung yung object is on the verge of slipping when surface is tilted at a critical angle, yun yung critical angle na malapit na siyang mag-slide, yung isang object na kinoconsider natin, yung coefficient of static friction between the object and the surface is simply equal to tangent theta or tangent nung angle na given. And this result is independent of the mass of the object. For example, yung critical angle natin for discrete is precisely the same whether gaano man kabigat yung object na kinoconsider natin.